I wanted to work through this kind of smaller one. This is the same procedure as before. Part of the problem is there's not enough here sometimes to get your hands around. It's almost like there's not enough here to know what to do. This does fall into the same category. This is the products of powers of sines and cosines. It's just that coincidentally in this case, this is cosine to the 0 power. If there is no cosine term, that's still cosine to the 0. 0 is an even number. And so we do have an odd power of sine or cosine. All right? So, whatever's odd, peel one of those away. So we can write this as, so that's reserved. What's left over after you peel that? After you peel that away, that's sine squared. And then once you've reserved off sine, this needs to get converted into the function that creates that differential, which is to say this needs to get converted to cosine. And we know how to do that. That's 1 minus cosine squared. And I think you should be able to take that home from here because now this is ready for the u substitution. Let u equal cosine of x. And that follows straight through. You gotta be careful with the negative sign here. But that follows through very straightforwardly. So if one of the functions is missing, it's still the same procedure so long as this exponent is odd. Person might say, well, what happens if they're both? What if it's even? Well, now this is not the same procedure as before because we don't have the exponents, one of the exponents odd. So what we do is you rely on, this is sine squared. And recall how we did sine squared. Sine squared, we have to use the half angle formula. That's why the sine squared integral and the cosine squared integral need to be in your comfort zone. Not just that you're able to do them, but you're able to recognize when you need to do them. The sine squared and the cosine squared need to be firmly ensconced in your comfort zone. To me, that's like a warm-up problem. It's like you get up in the morning, instead of doing some exercise and go out and take a run, you do a little calculus to get the blood flowing. That would be a good thing to do, is just wake up in the morning and do the antiderivative of cosine squared, just to make sure you have that in your comfort zone. So what we do here is, let's see. Yeah, this is entirely inside the parentheses. It's 1/2. The 1/2 is in parentheses also. It's going to get squared. This is 1 minus cosine 2x. But now everything in here gets squared. I'm going to square the 1/2 and then throw that constant multiplier out front. Square the 1/2, throw the constant. Be very careful with this 1/2. This becomes 1/4 because I've squared it. And now this gets squared. Remember, you have to use the FOIL method. This is 1 minus 2 cosine 2x plus cosine squared 2x. And now the problem is, that integral you can do, but that still needs some work. Cosine squared. Cosine squared, you do exactly the same thing again. See, we started with a 4th power, we created a cosine 2nd power, and now we need to do exactly the same process. So what I would do here, the thing to work with this, is now break this into these two pieces you can do, because this is cosine to the 1st power. If you have sine or cosine to the 1st power, that antiderivative, that's the 1/a rule, but that problem's not too much of a hassle. Now we're only dealing with just this piece. So now, from here on out, I'm going to deal with just this piece. All right? So just that piece, we have the antiderivative of cosine squared of 2x. How do you do cosine squared? You have to use this identity, but it has to be plus because it's cosine. So this is 1/2, 1 plus cosine. Now notice, see what we have here? That's why we talked about that in the previous video. If this is x, this is 1x, this is 2x. If this is 5x, this is 10x. If this is 2x, this is 4x. And so now we can write this as 1/2 antiderivative 1 plus cosine 4x dx, which is 1/2 times the expression. Reattach the variable, plus this is, what's the antiderivative of cosine? Antiderivative of cosine is sine. But we need the 1/a rule. And then if you want to simplify that to make it look nice, that's fine. You don't necessarily need to, but that is only this piece of that answer. You still need to do that portion, you still need to do that portion, and then combine that with this portion to get this long expression answer. But you see what's happening. A relatively simple integral gets broken down into this one, gets broken down into this one, and gets broken down into this one, which I have up here. So one integral gets broken down into this and this and this, and that gets broken down into smaller integrals. That's what I mean by this process. This whole thing's times 1/4. That's what I mean by this process of this problem gets broken down into little pieces, and each of those little pieces you need to know how to do, taking into account all these little details. Man, they say the devil's in the details, and this is loaded with it. The most common error students make is something wrong with these coefficients out front. So be really cautious with the coefficients, because they can arise from the identity. This two arose because we did the FOIL method. This 4 arose because of the 1/a rule. This 1/2 arose because of the identity. I mean, these constants arise from all over the place. And you need to make sure and keep track of all those constants just as much as you're keeping track of the functions involved.